everybody. So first of all, thank you very much for the opportunity you're giving me to be speaking here in this event. I've been actually quite excited listening to all the previous speakers and all the different views. Been working on the smart grids area, microgrid storage for many years. My journey started in 2004. And I was basically involved in technology development for many years, also assisting with policy and standardization efforts in connected fields, and developing partnerships and innovation projects on these fields. Just before I start my presentation, I'd just like to think about a couple of things I've heard. I've heard keywords that I would like just to highlight. So I've heard about flexibility. I've heard about the need that the power system has to adapt in real time to the changing conditions of its environment. I've heard about enabling technologies, the technologies that will be at the service of providing such flexibility. I've heard about having a layered down structure where the decisions might not be all taken centrally, but might have to be taken at the local level. So was a presentation with Patrick where he actually did mention that point, which is very relevant, especially because also mentioned previously, I've heard about sector coupling. And I'd like to develop just a little bit about those things. If we try to picture in our mind what all of that means, what could be the picture of the world where we're going to go? Because technology must be at the service of where we want to go as a society. So technology is not an answer in itself. It's a tool to develop and to grow to the future that we have selected and endeavored. If you look at this picture we prepared at LNT, it tries to sketch what we would call an ecosystem. On that ecosystem, you can see different actors. You have a wind farm, you have renewable plants, you have industrial parks, you have buildings and microgrids, you have electrical mobility. These are different sectors of the society. And whilst none of them are exactly the power system is the connecting binding force between all of them. So you see some things like substations which are close to all of these elements. Being close means you have the potential, especially with the drop in costs of CPUs, of memory, of storage, with the increase of communication technologies and digital layers, you have an opportunity that you have never had before to be able to integrate massive numbers of elements and aggregate them together in a layered approach, where you have centralized decisions of how to drive your system, what level of penetration of renewables do you accept, how do you filter and dampen those oscillations on a bigger scale, and then you basically layer down those decisions to more local systems that optimize with their own assets how the network should respond. And they basically will be able to enable large shares of numbers of devices to interact with the main system. Here, I was involved in a setup of a project in California maybe 2 years ago. And in that project, we were talking about a pilot with a utility. I cannot disclose the name. And one of the problems of the utility was, how do I integrate in real time more than 400,000 elements, and I interact with those seamlessly as they come on off the grid? How do I manage the mobility, electrical mobility, which basically means my load is moving in my system? How do I manage that? How do I aggregate all of these things? So this picture tries to sketch what that world could look like and what we would be talking about. We'll be talking about collecting data at the source, where it is generated physically, processing this data at the source to give us some benefit. We will be able to increase our stability margins. We'll be able to change dynamically our protection systems to be able to secure people, safety and equipment. We would be able to have coordinated controls, Because if you look at the picture, you see a lot of storage there. We've been talking about storage this morning. So you see storage on the microgrid, storage on the vehicles, storage on the renewable storage is everywhere. But is it doing the same thing everywhere? And if there is a disturbance on the network, how do I ensure that there is no cross-competition between the controllers in that storage? How do I make that happen within a real-time framework, within the next few seconds, where I don't have the time to go centrally, process everything, come back down? How do I manage when somebody new installs a new storage or a new inverter? How do I impact that and reflect that on the existing controls? So we need a platform, this is our vision, that allows to enable all of that aggregation, multi-layered, localized, and not only, and distributed horizontally and vertically. And this is what I would basically say as today is the smart grid. It's this layered infrastructure coming from the physics up to the cloud and enterprise, but not disregarding all the layers in between. Now, I'll stop here with the flexibility options for interconnecting all of these systems by saying that none of this is possible if we don't have a scalable, flexible architecture that allows to incorporate these at the least possible cost and to avoid stranded cost for the customers. Because by investing in any of these options, you basically put your money in some asset, and the technology, as we clearly saw in the previous presentations, is moving very fast. So what's happening in the mind of the customer is, shall I wait to make my investment, right? So this is a big white elephant in the room. Shall I wait? Can I afford? Or how do I invest without over-engaging and incurring too much of a risk? This is only possible if we have an integrated system and system of systems view. Okay? Now, as L&T, we've been preparing for this sort of scenario, and slowly we have developed different projects within India. You have some examples there, mostly on photovoltaics, floating photovoltaics, rural microgrids, and we have provided complete solutions also for guaranteeing the performance to the end user, to the end owner, and also to find the financing, to help with the financing schemes to actually make it happen. So that we have been building up all of that capability over time within L&T. Then, if I continue a bit further without going into too much detail here, same thing was happening for rural electrification. What is common between these two pictures? We have been working to a stage where we are developing project by project. So we have some development. We basically provide a solution for that development. What is not visible here, and not many people are thinking about today, is how do I integrate all of those developments for a common good? And how do I optimize their common throughput and the performance they can give to the end users to drive down the costs and increase the quality, which was also mentioned by the previous speakers, the power quality for our end users. Now, I just highlight this one for one reason. We've been working on microgrids, and our philosophy in L&T is that we like to taste a bit of our own medicine. So we basically develop our own projects in our own campus, and what you're seeing here is at the L&T headquarters back in Chennai, and it's a part of the solution in feeding our power every day. So when I go to the office, I have a microgrid operating, and I have a part of the power coming from this microgrid that we developed on our own funding to make sure that we have the capabilities to deliver these projects when the need comes on the field. So we continue to develop now bigger projects. We are now on the multiple 10 megawatt scale for storage projects development. This is under execution, and our plan is extremely aggressive towards investment on the renewables, energies, PV, wind, and on the storage technologies. Now, I would like to highlight, in terms of capabilities, our mindset. We have a continuous innovation and capabilities build-up mindset. Why? We develop our in-house tools to be as performant as we can possibly be, using digital technologies to be able to drive down project execution cost and project duration cost, so we can be exactly on time and our customers can expect a solution delivered as per the contract agreed with them. And this is not easy to do because these projects are of smaller scale, have a lot of projects that we need to manage in parallel with few resources, so you need to have a fantastic capability to be able to achieve this. So this is one of the areas which is non-technological, but that can benefit in terms of the credibility for the customers. We also have our own factories to assemble and containerize these solutions, so we can deliver a controlled quality on the field, and we can deliver this quality with speed. So we containerize, we test, and everything is then dropped on the field as a container to be able to speed up the execution time. And we also invest on technologies that allow for low maintenance and operation costs, for cleaning, for instance, all these arrays. In India, this is a problem with dust. So we've been thinking about this and how to deploy this in different orographies, in different terrains, and in different, let us say, slopes. I will conclude this presentation with some key takeaways. We have been talking about smart grids for many years, and I think now it's the moment where this is all happening worldwide. The growing opportunities are out there to be reached. A lot of things are becoming very mature, and in India, this market is also developing. This is driven greatly by cost. And usually what happens is when we go down below $100 per kilowatt hour, there will be a flood of demand for these technologies. And we have to be ready to be able to supply that demand. That was a message coming from previous speakers. For me, it resounded very well. Now, as you've seen from the examples here and probably in other conferences and other forums, we are now working on a one-off type of projects. So we develop some capability in some place, then some capability someplace else, but we are basically working in an isolated fashion. We need, my opinion, to evolve to layered system designs, to optimize the overall benefits for both the investors and the end users, because that's how you can enable the market and make it grow. To guarantee scalability of the control and management. So my regulation is changing. I need some new application. My God, I need some new application. How do I basically develop this? I'll take 30 seconds. Okay. Enable multiple stakeholder interactions. How do I put the industrial players to talk with the power system players, to talk with the EV players, and so on and so forth, in a way that the ecosystem allows for the operation to be executed across those sectors? And we need future-proof designs, because nobody knows tomorrow what new technology, what new need is going to come, and I do not want to have a stranded cost. I'll go to point number 3, the enabling factors. How do we achieve this? We need to have a system and system of systems thinking. We cannot just think about one asset and what that asset can do. This is not going to solve the problem. Storage, we've been discussing, it's one option, one key flexibility option that enables a lot of things and is enabled by a lot of things. So we have to understand that ecosystem. We have to really think about digitalization and real-time data sharing. How do I do this in such a way that I maintain the privacy for my customers, but I still enable the system to operate? And finally, how do I adopt my distributed controls and coordination to reach my resiliency targets, stability and flexibility? Took a little bit longer than I was expecting, but thanks for the opportunity.
Thank you very much, Luis. It was